Thank you, everybody. So I'm Shane Berger. I'm a principal and global leader for technical innovation at Woods Baggot. We're an international architecture practice. I'll get into a little bit about what that means in just a moment, but I actually want to go back, I guess, probably almost about 60 years, 62 years now, to 1962. There's a gentleman by the name of Douglas Engelbart. He was the founder of many of the concepts in human and computer interaction when he wrote an essay called Augmenting the Human Intellect, a Conceptual Framework. And he started off with this passage, which was about the augmented architect at work, in which he describes many of these features that we've all gotten to know within CAD and BIM over the years. And apologies in advance for the gendered stereotypes. This is 1962, but these passages in particular stand out. Next, he begins the functional analysis. He has a list of people who will occupy the building and the daily sequences of their activities. This clerk allows him to follow in each turn, examining how doors swing, where special lighting might be needed. And finally, he has the clerk combine all of these sequences of activity to indicate spots where traffic is heavy, or where congestion might occur, or determine where the severest drain on the utilities is likely to be. In this way, the computer has many other capabilities for manipulating and displaying information that can be of significant benefit to the human and non-mathematical processes of planning, organizing, study, etc. Ultimately, Engelbart's goal with this work centered on this idea of increasing the capability of man to approach a complex problem situation and to gain comprehension to suit his particular needs and to derive solutions to these problems. What I find fascinating about this is the entire beginning of computer user interface design and interactions began by imagining what an architect might actually do with these. So as we move into this, I want you to start thinking about everything I talked about coming forward and conversations through the course of the day today about how you bring that work to your own practice. So here's a few questions for you to think about as I present this work and the ideas. The first one, for you, what is the value proposition of your practice? How are you unique? Are you design-led? Are you around delivery and efficiency? What's the role of technology in your practice? Is it a necessary evil or a strategic differentiator? What's the role, how do you scale innovation across small, medium, and large practices? And then ultimately, how will this affect your staff? What's the relationship to automation? What's their role in knowledge sharing? What are you and they excited about? Because what frames this for me actually comes out of the book Machine Platform Crowd, which is the successful companies of the second machine age will be those that bring together minds and machines, products and platforms, and the core and the crowd very differently than most do today. So as I said before, I work as a principal and a global leader for technical innovation at Woods Baggot. We were founded 160 years ago by Ed Wood and Walter Baggot. And in those years, the firms, in the last 160 years, we've gone from building churches as a negative reaction to modernism in Adelaide, Australia, to this building, the Southern Australia Health and Medical Research Building that was built just a few blocks away. And through this, we developed a sequence of workflows and culture that has enabled multiple studios to collaborate across continents, across geometry and program, utilizing both BIM and computation workflows. And these sort of techniques developed on that previous projects and a number of other projects made their way into future efforts around design and control of complex patterns and into design modeling for fabrication workflows. Using an analysis grounded in human behavior to create sophisticated and exciting solutions for interiors. And ultimately, this ability brought forward material opportunities and limitations and considerations around fabrication and assembly. Those began to influence our design and execution of the work, creating a sort of digital craft into the language of our global studio. Now, I began this journey in digital craft about 20 years ago at the Smart Geometry conferences, where I met this amazing collection of designers, programmers, artists, and mathematicians. I actually met Martha at one of those events in 2010. And these workshops were these sort of active incubator environments around analysis and iterative prototyping, where we combined digital and physical design processes. It was a collective of explorers in design computation that were defining the next approaches to how we design our work. Now, at Woods Baggot, I've been trying to bring that sort of energy and culture to the practice. This is a project for Western Sydney Airport, where the project team members developed a geometric control system for the primary and secondary structure and for the final surface of these wooden slats. And this enabled them to create a design space for exploration while still preserving the ability to realize that idea in built form to be structurally sound. Each design iteration was examined across a number of factors, such as slat density, angle, and to ensure it fell within fabrication functional parameters. And with the result being this ceiling that diffused light from the roof with a sort of binary of solid and skylight, and creating the filtered effect at the level of activity below. Now, this was not the work of a specialty computation team. This was the project team itself. Putting that capability in the hands of the designers has been the focus of a lot of my work at Baggot. The work of our project teams often serves as an inspiration for this development of our suite of automation tools. And often we're taking ideas and scripts from projects, we're developing them further to make them more robust and more capable, and then deploying them across the practice. We've organized them into 3 different scales that you see on the left here. So there's utilities, those are single purpose tools. Sometimes you just want to automate something with a single button. Apps are more mid-size applications that we use to digitize entire sequences and workflows, whereas platforms are larger multi-process systems and infrastructure that is necessary to enable many of those other items on the list. So you see some examples here. At the very top, you have what we call the Wombat tools, which is a collection of utilities. In the middle, you see an example of some of our knowledge tools. We call that one Quokka, which is a natural language search app for finding automation tools and training. You'll notice, by the way, we have a tendency to name our tools after cute Australian animals. And on the right, you see what we call Flight Manual, which is focusing on connecting to our standards libraries, our model quality tracking tools, and guidance on best practices to advise on model quality. But one key item to always consider when you're building tools is the purpose, whether it be the automation of tasks or augmenting the design process. Automation is ultimately just providing answers for commodity-driven tasks, repetitive procedural things. So you can spend your time on other stuff, places where you want to bring value to your firm and to your own design process. Whereas augmentation is about creating an informed design space for exploration. Through augmenting design, this is how we create better designers. We provide them with better data at the right moment to drive better outcomes and to improve the feedback loop, the learning feedback loop. Using tools like Ladybug and Pollination, we've created a collection of apps and workflows around building performance that go from pre-design into concept design into design optimization. And these tools have been fundamental to our conversations with clients. We use them in front of clients when we discuss with them things around energy efficiency, occupant experience, and even climate risk, such as the work shown here for the LAX midfield projects. This project has been part of an expansion of transport capabilities for the 2028 LA Olympics, which aims for this project in particular aims for carbon circularity. Analysis and building models were crafted around creating a high-performance modular set of gates, fabricated landside just outside the security perimeter of the airport, and then moved airside via motorized transport to the location. This enabled construction to proceed in close proximity, but without the additional security logistics that you require being on the security side of an airport, and therefore a minimal assembly crew. The building can be moved in the future if the needs require it to be elsewhere, and all items in the design have also been tagged for future disassembly and reuse as needed in a carbon circularity approach. We've synthesized a lot of our performance analysis tools under this banner that we call Global Impact, which is also the name of our sustainability community. And all the information from these systems make its way into the Global Impact Assessment, which is a web-based tool that takes things like the AIA 2030 Challenge as a starting point and extends it into areas that we think are really important to our work. This allows us to track progress over time, but also supercharges our knowledge sharing around climate adaptation strategies. So in addition to building performance, we've developed a suite of tools focusing on spatial and programmatic performance that asks 3 fundamental questions. How do we move? How do we shape and negotiate our experience of space? How do we interact? How do we influence urban activity and how people use public spaces? And then lastly, how do we use analytic benchmark case studies to provide valuable indicators for comparing our designs? Now, I'll just note, this isn't just our work here. This is grounded on decades of shared academically funded research across a broad global computation community researching how to simulate human behavior. There's a lot of rich material and great researchers out there in academia and industry for any of you to talk and work with if this is something you want to get into. I believe that analysis should be tightly coupled with the design process. Achieving an informed and augmented design process is only possible with these really tight feedback loops. And for this reason, we build a lot of our spatial tools to be tightly coupled with our modeling efforts in Rhino and Revit. Our spatial data model is extracted automatically using things like NVIDIA's Nucleus technology, which is part of the Omniverse toolkit, and it's sent to an analysis farm of GPUs. The resulting analysis, covering topics like visibility, connectivity, compactness, then informs our interior designers across both our workplace and retail sector work. And as an extension of this work, we developed an agent-based modeling system for simulating circulation through space. This isn't about egress, it's about understanding the comfort and quality of the experience. By setting origin points, potential destinations, the quantity of people and the personas of those who might be there, and the character of the space, we can better understand how well space might perform as a dynamic entity itself. And this process can be extended into more complex network analysis, including work like the interior design of the Harvey Milk Terminal at San Francisco Airport, where we took the analysis of past airline passengers to inform the development of personas that represent the different kinds of people who use the terminal, business travelers, families. This was followed by simulating that sort of passenger flow with the different kinds of people who use it across the different various amenities to inform the layout for a highly performing design. And whether you use existing tools on the market or you build your own, the increasing ease at which we can analyze and simulate building and spatial performance should result in a growth of evidence-based design as a requirement from our clients. This should be a major and increasing source of value for our professions going forward. We build tools because they're an extension of our design thinking, and they're how we believe we bring an increased value proposition to our client. And I've become really interested in building this sort of strong network culture around computation and innovation in our practice. I believe that restricting innovation to a hierarchical or separate innovation team doesn't work if your goal is systemic change. If innovation is separate from the core of your work, you'll believe it's the work of someone else to do. It's not your job. No one should believe that innovation isn't their job. Whereas in a hierarchical environment, you have a self-organizing collection of emergent ideas of people where the goal is to foster knowledge sharing and spark creativity. And at Woods Baggot, we've created these kind of innovation and computation communities as a sort of safe place to share ideas, share knowledge, and challenge each other. And they're centered around the core mantra from Daniel Coyle's book, Culture Code, to build safety, share vulnerability, and establish purpose. But then after that point, we extend and supercharge that community with the core of our group, our design ops team. This team prioritizes elevating the concepts of project level computation to push up to organizational level systemic change. We look for patterns in projects. I was talking about that with people over lunch today, finding patterns in projects to guide our development work, and we turn those ideas into utilities or apps. And ultimately, the interest here is looking across how you build your tools. Actually, the session just before lunch spent quite a bit of time, and Zubi's presentation covered these exact topics. What it means to find and build the right product, to do with sort of systems thinking and workflow integration, and building it for the right audience. Because the biggest mistake you can make is building the wrong product, not just building it correctly or incorrectly. Ultimately, all of us are going to have to balance what we build with what we buy. But these tools that should all be doing, but we should all be doing this in a conscious way that's aware of the opportunities and limitations that each one of them afford. My strong preference is for openness. This also came up in the conversation before lunch as well. Tools that are open, that can work with others, where data flows easily, where tools are reconfigurable to both the needs of a project and the workflows of the people that are involved, where the core formats or protocols of collaboration are not proprietary. Software developer Gordon Brander put it this way, that creative work means piecing together unique workflows using many tools. The degree to which a workflow has been embodied in a single tool is the degree to which that creative act has been commoditized. This leads me to ask a question. If project delivery in Revit is a commodity, where are our opportunities for designing the future of the built environment? Because Brander goes on to say, if a tool supports composition with other tools, it supports open-ended evolution. And an evolutionary system will always be more expressive than one that isn't. We've gone through probably 4 different generations of improvements in technology and design process within architecture, starting with just the development of standard graphics approaches of communication, into digitizing those graphics, into automating aspects of those graphics, and then into whatever that last one is on the end. And that's where we get to, articles like the one released by Goldman Sachs in March, called "The Potentially Large Effects of Artificial Intelligence on Economic Growth." In it, they predicted 37% of the architecture industry will be exposed to automation by AI. Now, it's worth pointing out, however, that's not 37% of architects replaced, but 37% who will have their tasks modified by the infusion for AI. Because machine learning can help us deal with significant levels of complexity and can do so by interfacing with our real world. That's a lot of the big innovations, is the human interaction aspects, such as this example here of understanding the layering rules which they go through these parking signs. I think it would honestly take me about 20 minutes to diagram this out. It can also generate a wide variety of images based on what it's learned, sourcing from images and data from all around the world. If it's been trained on the work of artists or high-end photographers, what it creates will be seductive in just the exact same ways. What we appreciate about the work of those original artists will be what we appreciate about what it creates. It's trained on what's successful and popular, and it's very convincing. But once you start interrogating the details or wanting to refine what it creates, you run into problems. You start to see oddities in what it creates that defies logic, oddities that are very inhuman. And this is because generative AI is just upgraded autocomplete. The same autocomplete you see on your phone when you're texting or in Google when writing an email, with all the same benefits and the same mistakes. Machine learning systems can both believe that the Earth is flat and the Earth is round at the same time. How it answers you is simply a matter of being statistically more likely that you want to hear it's round. The idea that these tools are intelligent beyond statistics is more a facet of our human empathy than their actual capabilities. We love to anthropomorphize. Think of your pets. Neither ChatGPT nor Midjourney or a lot of these diffusion systems understand physics. They don't have spatial awareness or perceptual constancy. It doesn't have a model of what it's like to be a human in the world. In the specific case of diffusion models, this can result in some odd conditions like those shown in this stair here. Midjourney generally knows what a stair should look like based on its training from 2D data, but it does not know how it functions in 3-dimensional space. These are statistical models, not mental models of the actual world we live in. And yes, it is absolutely getting better. Current AI images are less likely to make mistakes like give you 6 fingers or extra arms, but that's not because it better understands human anatomy. It's because these companies who train their models employ thousands of low-paid workers to rate the quality of images that it produces as part of a reinforcement learning process. These workers did not teach it how the world works. They just improved the statistical model for the specific errors that they noticed. My concern is that with certain types of creativity will dominate our profession because they're just so easy to do with AI. And that is devaluing our profession. And in doing so, we'll miss out on some truly transformative innovations in our culture. It will only produce iterations based on what it's already seen and what it's already trained on. And creativity will be dominated by the lowest common denominator, by the kinds of creativity that is easily democratized by software. By way of example, what happens when I reference that Southern Australia Health and Medical Research Institute into a prompt? It generates 24 more versions of it. When I ask it a health and medical research building like SAMRI, that's what we tend to refer to it, and with some information about the image setting in front of a nice river with a beautiful, background. However, the ease to which you can remain in this sort of derivative creative space and even directly reference the creative work of others prevents you from exploring much wider opportunities. Because no matter how much you want to believe it, to channel Renee Magritte, this is not a building. Author Kate Crawford notes that we can easily forget that classification systems that are casually chosen to shape a technical system can play a dynamic role in shaping our social material world. The people who wrote all these words online and our source for ChatGPT or the art for Midjourney are predominantly white, Western, male, and comparatively wealthy. I gave Midjourney the prompt, 5 architects standing in front of a modern building. Out of the 24 images, only 2 contained women and only 3 showed any apparent ethnic diversity. White men dominate because to AI, based on statistical thinking, architects are white and male. If it demonstrates this level of bias regarding a gendered profession, the same is arguably true regarding art and style, which is also predominantly modern Western culture in these systems. When we use these tools, are we conscious of how it might steer us based on purely what it's trained on? Beyond creativity, what does it mean to be an architect or interior designer? I do not care that ChatGPT is able to pass exams. Exams are not the kind of knowledge that constitutes the bulk of our profession. Exams will tell you you meet the legal requirements to be an architect, not that you're any good at it. So where do we go from here? A little over 7 years ago, the book, The Future of the Professions, came out and it discussed the various avenues of disruption to bear through technology. And the framework of the book can be summarized by this quote: if knowledge is indeed the heart of the professions, 2 questions must follow. The first, how are the professions at producing, capturing, nurturing, and reusing their knowledge within their own organizations? And the second question, might there be a different and better ways of producing knowledge and making it available to society, methods that might not directly involve the traditional professions at all? Now, I would imagine many of you might agree that the profession of architecture often fails at the former, the capturing, reusing, and nurturing of knowledge. And for the latter, I would say that the obituary for the architecture firm need not be prematurely written. Because I even view that there's opportunities through data and AI in our approaches. And it comes across 2 different dimensions, being interface and infrastructure. By interface, one of the things I reflect on is that a major part of what made ChatGPT and Midjourney so powerful was the ability to connect people with machine learning through human-like interfaces, through our language. Everything else behind that was built on decades of research and didn't seem like so much of a leap. On the second side, for infrastructure, it's the ability to supercharge many of our existing processes through applied machine learning techniques to solve existing problems. Because our greatest innovations will come not just from technology itself, but from the novel application of technology to our work. And I'm going to review those 2 things across these 4 parts here: human interface, evidence-based design, informed automation, and co-pilots. So the first area of impact with AI is the creation of new human-centric interfaces for our work, interfaces like narrative, sketch-based, or spatial or visual, such as the ability to use sketches or sculptures to input in a generative AI to iterate on different concepts. Or to use narrative, descriptions of spaces and experience to create evocative imagery. Conscious of everything I just said about AI creation being derivative, I do feel there's a place for generative image work in the design process, provided you understand issues around bias and creative limitations. We found that the right spot for us is in the generation of content from mood boards as part of a narrative design process, telling stories, not creating architecture, but telling stories about experiences. Let it be your fanciful, totally unrealistic design partner or intern that it may prompt new transformative ideas to come into your very human head. What it creates is not the design, it's not the solution, but perhaps a mood, a feeling, something that is evocative of the character you're aiming for. And as part of this team conversation, it's also part of what influences the design. And in that manner, it becomes a new medium for creative thought. If you're trying to evoke the character of a natural space you've been to, as in this case, where we're using the materiality of local rocks in Australia and using it to create natural and unnatural forms, then the AI doesn't need to get you to a solution as long as it prompts ideas. The second area is evidence-based design. And for this, to quote Simon Sinek in his book, Start With Why. Very few people or companies clearly articulate why they do what they do. By why, I mean the purpose, the cause, the belief. People don't buy what you do, they buy why you do it. And for us, it begins with how we start our work, our use of data to better understand a place, how it might perform, the environmental, economic, and social climate. And this is work I've been progressing with the data scientists on our team, working with our urban systems team around place intelligence. And by understanding the performance potential of a space across how the streets and transportation function, land use, population, and we start to rank open spaces with that through multiple methods of calculating attraction and accessibility, we're able to better understand the potential of a place. This is where design should start, using design, data, technology, and even artificial intelligence to sort through complexity to help us better understand a place. And once we have those series of design proposals, you can move into the opportunities to better understand the performance on the project itself. This is evidence-based design, and AI can supercharge this. Evidence-based design becomes a differentiator in the value that we bring to our clients. This is how we bring critical inputs to thoughtful outputs. We do not need AI or automation to make it easier or faster to just build the way that we've always been building. Novelty and automation have their place, and that place needs context. And unfortunately, our context is on fire. What are we going to do with this technology? If we're faced with one of the most important challenges in history, empowered with the most powerful technology ever invented, are you just going to use it to make novel images of architecture or a faster parking garage? Or use it to bring a better societal good to the built environment? Our use of technology should enable us to be more empathetic actors in the world. Uninformed automation, can you use access to past knowledge? And again, portions of the last panel were showing this as well. Access to past knowledge and iterate through variations to help you find multiple, optimal outcomes for multiple objectives. This is some work that was done by our spatial analysis team to iterate on residential design layouts across program and financial outcomes. Can we train machine learning algorithms to constitute what's good design and have it get us to a better starting point for residential and workplace layouts? It's not going to give you the answer, but it gets you 80% there. It'll be up to us designers to take it from good to great. Can we take what is sometimes a repetitive task, like dimension annotation, and train a machine learning algorithm to automate it? We do run into a problem in this sort of space. Machine learning requires millions and billions of data points. We don't have that much data, not in a single practice. We would need to get to a point where we're starting to share this information as a collective industry through a data trust. And finally, knowledge co-pilots. And this is where AI provides better access to relevant knowledge within the context of your work, like the examples of both Upcodes and ChatGPT. It's worth pointing out here, a lot of this concept comes out of what MIT professor in AI, Marvin Minsky, used to refer to as the society of the mind. This idea that you're going to have a swarm of AI bots around you, not one big AI that does architecture, right? It'll be a swarm that does collections of microtasks to augment everything that you do. And in my own path to collecting and increasing access of knowledge, I've started to use tools like second brain tools like Obsidian. I actually use that to produce this presentation. This ability to explore ideas, connect ideas together, learn about how my own knowledge collection and things that I've read and things that I developed are actually connected to other ideas. And these are places where AI can start to come in to help find those emergent ideas to expose them to the rest of the world and the work that you do. But ultimately, creativity doesn't happen inside people's heads. It's at the intersection between their thoughts and a socio-cultural context. It's systemic rather than individual. Sorry, just a second. This is something that came from the psychologist and author Mihai Csikszentmihalyi in his book on creativity. And in that sort of spirit, one of the things that we've done at Baggot is we built a tool called the Design Intelligence Portal. It's sort of a Instagram around knowledge for projects and knowledge communities. We've been running this for about 8 years. People post projects, tag ideas, share across the practice. It's our first kind of implementation of this second brain concept, but across the entire practice. And with this, we're using it to test some of our first knowledge bots to be able to train on that design narrative of a bunch of our projects. The opportunities are expansive. You could ask this design intelligence bot about projects that use timber structures or approaches to workplace innovation or global impact strategies. This is a place that is for right development for all of you. And a lot of the systems that are out there there's many that are fairly low cost and a lot of open source and free ones. What I'm interested in here is that we as design technologists should be interested in how we develop tools for thought. Places that create a powerful immersive context where the medium itself expands the potential range of thought. And I referenced just a bit ago, Mihai Csikszentmihalyi's work in creativity. He also talked about this concept of flow state. which is about balancing the level of challenge for a project with that person's skill level. I'm sure many of you, when you're working in a lot of your tools, feel those emotions in the bottom left-hand corner. Those are going to be very common for us. But our goal here as design technologists and as an industry should be to use technologies to help our designers achieve a form of collective flow state that's in the upper right, matching challenge with skill. So ultimately, in the end, this is about augmenting design and delivery, not just automating it away. It's about helping us ask better questions, not constrained answers, and helping us build better relationships with your peers through technology, not just point-to-point transactions. Because my goal as a design technologist is to help foster a culture that is more informed, of empathetic designers through technology. Thank you.